Hello students, welcome to Power Tutorials. So today we are going to start chapter 9, that is some applications of trigonometry of NCERT class 10 maths textbook. So before going to this chapter, let us recap the previous chapter details, which is all 6 trigonometry ratios and 5 angles, that is 0, 30, 45, 60 and 90 degrees. So let's write all the details. That is for starting sine, second trigonometry ratio is cos, third is tan, then we have cosecant theta, then we have secant theta, the last one is cot theta. So the 0, 30, 45, 60 and 90 degrees. So let us draw a table so that you can easily read it. So mostly questions will be on these 5 degree angles only. So these are degrees and these are the trigonometric ratios. So sine 0 is 0, sine 30 is 1 by 2, sine 45 1 by root 2, sine 60 is root 3 by 2 and sine 90 is 1. To remember cos, the only easy trick is just take opposite of sine. So 1 root 3 by 2, 1 by root 2, 1 by root 2 and 0. What is tan theta? Tan theta is sine by cos. That is 0 by 1 is 0, 1 by 2 by 1 by root 3 is 1 by root 3. But the same here, so 1, here it is root 3 and this is undefined. Cosecant theta is 1 by sine. So 1 by 0 is undefined. 1 by 1 by 2 is 2, 1 by 1 by root 2, so it becomes root 2, 2 by root 3, and this is 1. Secant theta, it is just opposite of cosecant, so 1, 2 by root 3, root 2, 2 undefined. Cot is inverse of tan. So it will be infinite root 3, 1, 1 by root 3 and 0. So you have to remember at least top 3, that is sine, cos and tan, so that for others you can directly take the inverse of these values. Clear? So another important point is we have to remember the definitions of all 6 trigonometry ratios. That is sine theta can be written as opposite side by hypotenuse, whereas cos theta can be written as adjacent side by hypotenuse, whereas tan theta will be sin theta by cos theta, which is opposite side by adjacent side. So which we are talking about, suppose this is a triangle here and this is theta, then this is called opposite side, this is the adjacent side and this is hypotenuse. Okay, so based upon the requirement, you can use sin theta, cos theta, tan theta. That is opposite by adjacent, opposite by hypotenuse, adjacent by hypotenuse, or opposite by adjacent side. So the rest three are, as already told you, it's the inverse of those. That is cosecant is 1 by sin, secant is 1 by cos, and cot is 1 by tan. Okay. Now let's see regarding this chapter, that is applications. So applications is that we are going to use these 6 trigonometry ratio values or these definitions with respect to the applications, and we are going to solve the real case application. The first application we are going to discuss about is heights and distances. So let's first understand what's the height and distance. So height is nothing but the distance, I mean the length of the object. Length of object from ground, that is earth, to top of it. For example, let's take tower, that is cell tower. If I take it example like this. So if I say what is the height of tower, then it's the distance from the ground to the top of it. So this is height. Same way I can also say for, suppose there is a building like this. What is the height of the building is? It's the distance from the bottom to the top of it. So this is respect to height. And same way the distance. So distance in sense the length between any two objects. can say that I have a point A and I have a point B. Suppose point B, we have a building here. Then the distance from A to building will be the distance between them. For suppose if I say x meters, then the distance between these two points is x meters. Okay. So in this heights and distance concept, we have two angles we have to remember. Angle of elevation, second is angle of depression. The angle of elevation is, suppose we have a point A here and we have a, suppose at point B we have a, suppose a building, and from point A if I am able to see the top of the building with some angle theta, then this theta is called angle of elevation. Angle of depression is opposite case, like we have a building and someone is standing on that building, and we have a, on the ground we have an object, suppose at B, and from point A, the top of the building, someone is seeing the object B, and with respect to horizontal, this makes an angle of theta. So this is called angle of depression. So as per parallel lines, if a line is intersecting both of them, then this angle and this angle will be equal. Those are alternate angles. Hence, angle, suppose this is O, OCB will be equal to CBA. So this angle and this angle will be equal, as those are alternate angles. Okay, now we will apply this concept and try the first example which is there in the textbook. They are saying that the tower stands vertically on the ground from a point on the ground which is 15 meters away from the foot of floor. So here they are saying that we have a tower. Let's draw like this, which is 15 meters away from foot of floor, foot of tower. So at the 15 meters distance, we have an object. The angle of elevation to the top of tower is found to be 60. So angle of elevation to the top of tower is 60. They are asking to find height of tower. Find height of tower. So let us assume the height is h. So if you see, this is as a right angle triangle, which is opposite side is h, adjacent side is 15 meters, and the angle is theta. So as per the previous slides, I have told you that opposite by hypotenuse, what is it? Sine theta. Sorry, we need to use opposite by adjacent side. Opposite by adjacent is, we need to use tan theta here. You can see opposite by adjacent. So let's use the same concept here. If I use tan theta, that is tan 60, because theta is 60 here, tan 60 is equal to opposite by adjacent side. Opposite is h, adjacent is 15. What is tan 60 value? Tan 60 is root 3. Root 3 is equal to h by 15. So if you do cross multiplication, height of tower will be equal to 15 root 3 meters. So if you solve, root 3 value will be 1.732. If you want in decimals, it will be 25.98 meters. Hope it is clear. Let's solve second example. An electrician has to repair an electric fault of a pole of height 5 meters. So here we have an electric pole. Electric pole height they have mentioned as 5 meters. She needs to reach a point 1.3 below the top of the pole to undertake the repair work. Okay, so she has to reach a point here 1.3 meters below to find the repair work. Okay, what should be the height of the ladder that she should use with which one inclined at angle 60 degrees to horizontal? So from horizontal the angle is 60 degrees. So this is 1.3, this is 60. Would enable her to reach the required position. Also, how far from the foot of the pole should she place the foot of the ladder? Okay, they're asking this distance, and they're also asking what should be the length of the ladder. So they're also asking this distance. So to first understand, this total is 5. So if you have to subtract 5 minus 1.3 to get this value. Okay, so this value will be 5 minus 1.3, which is 3.7 meters. So this length is 3.7 meters. Now let's use, this is opposite side, this is hypotenuse. To find the length of ladder, we have to use opposite by hypotenuse, that is sine theta. So sine 60 is equal to 3.7 by y. So length of ladder is equal to 3.7 by sine 60, which is 3.7 by root 3 by 2. So 3.7 by root 3 by 2 will become 3.7 into 2 is 7.4 by 1.732. So it will be 1774. 7.4. 17 3s are 51, 17 5s are 65. 17 4s. 17 4s are 68. 17 5s, 17 3s are 51. So somewhere you will get around 4.3 meters. 4.3 meters approx. Let's see the next. Okay, this we got the length of ladder. We also want the distance between them. So for this is opposite, this is adjacent. Opposite by adjacent, we have to use tan theta. So tan 60 equal to opposite by adjacent. Opposite is 3.7 by x. 3.7 by x. Tan 60 is root 3 is equal to 3.7 by x. So implies distance between ladder foot and the pole foot will be 3.7 by 1.732. So the approximate value will be around 2.14 meters. Okay, 17 2 is 34, 17 ones you will get somewhere around this one. Okay, so in this way, the second example has been solved. Let's get the third example. An observer 1.5 meters tall is 28.5 meters away from chimney. The angle of elevation of the top of chimney from her eyes is 45 degrees. What is the height of the chimney? So you can see here we have an observer. So this observer is 1.5 meters tall and she is 28.5 meters away from chimney. So let's suppose we have a chimney here. The chimney is 28.5 meters away. Okay. And from her eyes, the angle is 45 degrees. So from here, the angle is 45 degrees. So let's take this as imaginary line. So this angle is 45 degrees. They are asking what is the height of chimney. They are asking to find this h value. Okay. So if you see here, we have to subtract 1.5 from total height, so that this height will be h minus 1.5 because the total is h. The observer is 1.5 meters. So in this way, let's use this point here and let's use this distance and this one. This is opposite by adjacent. So again, we have to use tan theta. So tan 45 is equal to, here we have to take h minus 1.5 because we have to considering from the height of the observer. It is not from the foot of the observer, it is taken from the top of the observer. So that's we have to minus 1.5 to get this value. So h minus 1.5 by the bottom is 28.5. So tan 45 is 1. 1 is equal to h minus 1.5 by 28.5. So if you cross multiply, 28.5 will become h minus 1.5. So h is equal to 28.5 plus 1.5, which is 30 meters. So the chimney height will be 30 meters. Okay. So let's start meeting again with another video where they will start explaining from example 4 solution. Thank you so much.